The James Webb Space Telescope, JWST, has opened a new chapter in our understanding of the cosmos, pushing the boundaries of what we thought possible. Recently, the telescope identified 15 galaxies that seem to challenge the very foundation of modern astrophysics. These galaxies, existing before what we believe to be the age of the universe, may rewrite our understanding of the cosmos. Since its launch, the JWST has been blowing our minds with discoveries that not only astonish the scientific community but demand a re-evaluation of long-held theories. At the heart of this new cosmic frontier are galaxies that, according to our current models, should not exist. Beautifully shaped and seemingly older than the universe itself, these distant galaxies set distance records while overturning common models of galaxy evolution. Since the summer of 2022, reports have been coming thick and fast, galaxies so ancient that their very existence seems impossible. This has prompted many to reconsider some of the most fundamental aspects of cosmology, including the widely accepted theory of the Big Bang. For decades, the age of the universe has been calculated to be about 13.8 billion years. This number has been adjusted several times, but the consensus remained more or less stable until recently. However, the new discoveries by JWST cast doubt on this figure, suggesting that the universe might be much older, or that our understanding of its expansion and evolution is flawed. A key pillar of the expanding universe theory is the phenomenon of redshift, where the light from distant galaxies is stretched to longer, redder wavelengths as they move away from us. This redshift has been interpreted as evidence of the universe's expansion, but new data from JWST suggests that this interpretation may have been wrong. Could it be that the redshift is caused by something else entirely, such as the interaction of light with interstellar matter? If so, the idea of an expanding universe and the Big Bang could be in jeopardy. The Swiss astrophysicist Fritz Zwicky proposed an alternative theory nearly a century ago, which he called tired light. According to this theory, light loses energy as it travels through space, causing it to become redshifted. This would mean that the universe is not expanding, and that the Big Bang never happened. While Zwicky's theory was largely dismissed in favor of the expanding universe model, the new data from JWST has led some scientists to reconsider it. What if the universe isn't expanding after all? If space isn't expanding from a single point, then we must rethink many of our ideas about the universe, including how it will eventually end. Theories like the Big Rip, where the universe expands so much that it tears itself apart, or the Big Crunch, where the universe collapses in on itself, all depend on the idea of an expanding universe. But if that expansion doesn't exist, we may be living in an infinite universe, a bubble universe, or even a 12-dimensional one that we can only partially comprehend with our current physics. This brings us to a fundamental question: can we ever determine the true age of the universe? As things stand, we don't know if we will ever be able to pinpoint an exact age or size for the cosmos. With each new discovery, more surprises seem to appear, leading us further into uncharted territory. Just a few centuries ago, people believed the Earth was flat, and even astronomers thought the Sun revolved around the Earth. Today, we are looking back over 13 billion years into the cosmos, only to find more mysteries that defy explanation. One researcher, Rendra Gupta, proposed in the summer of 2023 that the universe could be 26.7 billion years old, or even older. His calculations are based on new findings, including Zwicky's tired light theory and a revision of cosmic constants. While these ideas are still being tested, they have sparked intense debate within the scientific community. Could it be that the universe is far older than we've previously imagined, or are we simply missing key pieces of the puzzle? As JWST continues to peer deeper into space, it may uncover even older galaxies and phenomena that defy our current understanding of the universe's age. Imagine if, 14 billion years ago, the universe looked exactly the same as it does today. Such a discovery would force us to reconsider the timing of the Big Bang, or even its existence. What is certain is that each new finding brings us closer to a more accurate understanding of the cosmos, though the road ahead remains full of questions. For nearly 100 years, observations of black holes, galaxies, and the dynamics of the universe have largely supported existing models of physics. But the recent discoveries from JWST have triggered a crisis in astrophysics. It seems that the more we learn, the less the patterns of the universe fit with the ideas of the Big Bang and the expansion of space. Something, it appears, is fundamentally wrong with our understanding. This crisis, however, is also an opportunity. Physics has long been divided between the study of the very large, the universe as a whole, and the very small, quantum mechanics. These two realms of physics don't fit together mathematically or empirically, but they must be reconciled if we are to understand the true nature of the universe. Quanta, after all, are the building blocks of stars, planets, and galaxies. If these two disciplines don't match up, the problem lies not with the universe, but with our theories. The current crisis in astrophysics could be a turning point for science. Researchers who have clung to outdated theories may soon be forced to step down, while younger, more open-minded scientists are eager to explore new ideas. Michio Kaku, a leading astrophysicist, has described the JWST's findings as a revolution, calling it the moment when the inconsistent house of cards, that is modern astrophysics, begins to fall. Kaku has long advocated for uniting quantum physics and astrophysics, and he sees the JWST's data as a key step in that direction. The challenge now is whether the scientific community can come to a consensus. Scientists are notoriously stubborn when it comes to defending their theories, even when new data challenges them. This scenario is somewhat reminiscent of the Middle Ages, when Galileo Galilei was imprisoned by the Church for suggesting that the Earth revolved around the Sun. Today, scientists find themselves in a similar situation, where new evidence from JWST is forcing them to question long-standing assumptions. There is hope, however, in the younger generation of researchers. Scientists like Harvard doctoral student Rohan Naidu are excited by the JWST's findings and eager to explore new possibilities. Naidu was among the first to use an algorithm to analyze data from the JWST's deep field image, which led to the discovery of Glass Z13, a galaxy that dates back 13.6 billion years. This discovery was one of the first signs that the old models of galaxy formation and evolution were in trouble. The discovery of galaxies like Glass Z13 has been a wake-up call for the scientific community. Initially, Naidu's results were met with skepticism, but they have since been confirmed multiple times. This was the beginning of a crisis in astrophysics, as the redshift method used to determine the age of galaxies came under intense scrutiny. Many scientists began to question the accuracy of JWST's data, but the findings held up under peer review. The JWST has brought down what Michio Kaku calls the house of cards in astrophysics. The telescope's discoveries were unexpected, and many older scientists had anticipated that JWST would confirm their theories. Instead, it has done the opposite, shaking the foundations of modern cosmology and forcing a re-evaluation of long-held beliefs. But this is not the end of the story. As the JWST continues to collect data, more peer-reviewed studies are expected to emerge. These studies will likely lead to further revisions of our understanding of the universe, as errors are identified and new ideas are tested. What is certain is that we can no longer take for granted the truth of theories like the Big Bang and the expansion of the universe. In light of the JWST's discoveries, some researchers, like Sir Roger Penrose, have called for a return to the basics. Penrose, a British astrophysicist and Nobel Prize winner, has warned that we need to go back to reliable data and observations. He suggests that all theories based on dark matter should be reconsidered, as we still don't know whether dark matter actually exists. If dark matter is proven not to exist, it would mean the collapse of much of modern cosmology. At the same time, another telescope is quietly working in the background. Euclid, launched in 2023, has the mission of mapping the entire cosmos visible from Earth. While JWST focuses on individual galaxies and distant points in space, Euclid's wide-angle approach is designed to map the large-scale structure of the universe. Euclid may help answer some of the biggest questions in cosmology, such as the existence of dark matter and dark energy. The stakes are high for those scientists who have spent their careers studying these hypothetical entities. If Euclid's data fails to support the existence of dark matter or dark energy, it will be another blow to the current models of the universe. And if these two variables are proven not to exist, it will force yet another major revision of our understanding of the cosmos. As we stand at the threshold of a new era in astronomy, one thing is clear: the best discoveries are yet to come. The JWST has already shattered many of our assumptions, and the future promises even more revolutionary findings. With each new observation, we take another step closer to understanding the true nature of the universe, though, as history has shown, that understanding may be more elusive than we ever imagined.